In question 9, we're given two smooth spheres of masses 4 and 2. And they impinge obliquely. The 2 kilogram mass is brought to rest. So we have 0I plus 0J. And the coefficient of restitution is a half. Prove that before impact they were moving in directions perpendicular to each other. So we'll be looking at the slopes possibly here. So we don't have sphere A, let's call it, or sphere 4. So we'll call this Pi plus Qj, and then PQ or in the I direction, and the J is not going to change, Qj. And this one we'll call it Ci plus D into the J direction, and we'll see where we go from here. We're asked to prove that they were moving in directions perpendicular to one another. So 4 times P plus 2 times C is equal to 4 times R plus 2 times 0. So we have 4P plus 2C is equal to 4R. So we have 3 unknowns here. Let's see where we go next. Newton's law of restitution. We're going to have R minus 0 over P minus C is equal to minus 1 over 2. So we're going to get 2R is equal to minus P plus C. And if I try and eliminate a variable here, I have 2R. I could say 4R down below. I have 4R equals. So let me write this one as 4R equals minus 2P plus 2C. Will that help me down below? 4R equals minus 2P plus 2C. Now, if I multiply this one by minus 1, I'm going to get minus 4P minus 2C equals minus 4R. So I can actually cancel two variables here. So that's where this question is going. Minus 6P is equal to 0, so P is equal to 0. So will that help us? So P is equal to 0, 4R is equal to 2C, 2R is equal to C. And if 2R is equal to C, so we just write this out again. We now have 0, P is 0, 0I plus Qj. Actually, I don't think we need to solve these too much more, because if we have slopes of 0 and undefined slopes, which is what we're going to have here, we know that if this is 0I plus 0j, then the d here has to be 0. J remains unchanged. So we have slopes here of q over 0, which is perpendicular to 0 over q. This 0 slope and your undefined slope are perpendicular. So that's what they're looking for here. Then we're asked to show that the kinetic energy gained by the 4 kilogram mass is equal to half that lost by the 2 kilogram mass. So what do we have? We have 2R is equal to C. So let's see, will that help us here? We have 2R is equal to C. And if we set up our equations again, we have Pi plus Qj. So your 0I plus Qj. We have Ci plus dj, Ci plus 0j, we said for d. We have our 4 and our 2. And we called the other side Ri plus Qj. And the other one is at rest, 0y plus 0j. So we have 2R is equal to C. So we can change this C here to 2R in the I direction plus 0j. And we can probably go from here for kinetic energy, a half mu squared. So if we look at this one first, a half times 4. We just have our q, square root of q to be squared, so q squared. Square root q squared to be squared, so it's just going to give me a q squared. So we're going to 2q squared. Before, after, for the 4, we're going to get a half by 4 by, we'll end up with r squared plus q squared. The square root of r squared plus q squared to be squared. So it's going to be 2r squared plus 2q squared. This is going to help us. The second one, we have a half times 2 times 2r to be squared, c squared, which would be 2r to be squared, which is going to be 4r squared. What are we asked to show? We're asked to show that the kinetic energy gained by the 4 kilogram mass, so the 4 kilogram mass was 2q squared, and it became 2q squared plus 2r squared, so the gain for the 4 kg was 2r squared. So we're asked to show that that's equal to half that lost by the 2 kilogram. Well, the 2 kilogram was 4. It ended up at rest, so lost 2 kilogram lost 2r squared, or 4r squared over 2. QED.